Hey Wheaton North, this is Mr. Frittner. Today we're going to be talking about moles. So first off, what even is a mole? It's not what you might typically think of a mole being, the animal that we all know and love, but instead in chemistry when we're talking about moles, we're actually using that term mole to describe how many things we have. Just like we use some of these words like single to mean that we have one thing, pair means two things, and so on and so forth. A dozen means 12. Baker dozen, we know, means that we have 13. Saying that we have a mole of something is the same exact thing. It's just telling us a different number. And this time it's telling us that we have 6.02 times 10 to the 23rd things. That's writing it in scientific notation so that we don't have to write out those 20 zeros that you would have to not in scientific notation. So 6.02 times 10 to the 23rd things. That's what a mole means, is that you have that amount of whatever we're talking about. And in chemistry, we usually use moles to talk about atoms and molecules. That's why we need such a large number, because atoms and molecules we know are such tiny things, we can't even see it with our bare eyes. But 6.02 times 10 to the 23rd atoms, a mole of atoms, we can see. That's large enough that we can see it sitting on a table, making it a lot more useful for us to use and talk about. So the picture on the screen right now shows us a couple different substances, and it shows us a mole of those substances. So a mole of sulfur, a mole of potassium dichromate, and a mole of graphite. So you can see that that's actually, a decent amount. 32 grams, 294 grams, 12 grams. These are amounts that we can see, measure, and talk about. This is why we use moles. So how do we actually get to a mole of something? How do we know that what we have in front of us is a mole? We can't really just take out each individual particle and count them up until you have 602 hexillion atoms. You can't count that. We wouldn't have the time to count it. We can't see it to count it that way. But what we can do is use weight. We can use a balance, measure the mass of something, and know from that mass how many atoms we must have. That's why it's useful to know how much a mole is, so that we can talk about it in terms of moles, in terms of that mass that we are weighing. So for example, going back to that same picture, if we have 32 grams of sulfur, we know that that is 1 mole of sulfur that we have in front of us. If we instead had 64 grams of sulfur, that would mean that we had 2 moles. So this makes it a lot easier than talking about it in terms of atoms, where if you had 64 grams, you would have to say something along the lines of 12.04 times 10 to the 23rd atoms. That's too much to comprehend. We don't want to do that. So we're going to say 2 moles instead. And so this is a really easy way of determining how much of something there is. It's just we know how many grams of a substance is in 1 mole, so we can just talk about how much of that substance we have in terms of moles, just like you're seeing on the screen. And we'll show you how exactly to do this in just a bit here. But first, let's talk about something more familiar, just counting molecules, elements, and atoms. So in this first example at the top, we have a molecule N2O3. It's written on the right, the picture is on the left. And if I ask you how many molecules are in that, it's really just 1 molecule. N2O3, it's 1 molecule. How many different elements are in there? Well, there's nitrogen, there's oxygen, so there's 2 elements. You could find that by looking at the equation, see the N and the O, or even just look at the picture. There's blue atoms and there's red atoms. That's 2 different kinds of elements. And then if we count up the total number of atoms, there's 2 nitrogen, 2 nitrogen, 3 oxygen, so 5 total. And again, you could find that from the equation, or by counting up the atoms in the picture. If you go down below that, now instead of looking at just the one molecule of N2O3, we're going to look at 4 molecules. That's what the coefficient of 4 in front of it tells us, is that there's 4 molecules, and you can also see that drawn out in the picture. Now there's still 2 different kinds of elements. We're not changing that. We're still only dealing with nitrogen and oxygen, but the number of atoms is going to change because now there's 4 molecules instead of 1. So the number of atoms is also going to be 4 times as much. So now it's going to be 20 atoms because there's 4 molecules which all have 5 atoms in each of them. Now this shouldn't be new information, but this will be very useful for determining the number of moles that we have and the mass of something. So when you have a molecule like that, and let's say we have 1 mole of N2O3, we can tell from that how many moles of nitrogen and how many moles of oxygen we have inside those molecules. If there's 1 mole of that molecule, there's actually going to be 2 moles of nitrogen. You can tell that from the fact that there's 2 nitrogens in each mole, so you're going to need 2 moles of nitrogen to create 1 mole of N2O3. Similarly, 3 moles of oxygen are going to be needed to create 1 mole of N2O3 because you need 3 oxygens for each molecule that you're creating. Now let's talk about molar mass. So molar mass is how much mass 1 mole of a substance will have. How do we calculate it? Well, we look at atomic mass. We know how to find that. It tells you on the periodic table. You just look for the element you're looking for, and it tells you the atomic mass of it. For our purposes, we're always going to round that to the nearest whole number when we're talking about molar mass. So let's take a look at an example. We want to find the molar mass of calcium. For number of molecules, we're going to say 0 because we're just looking at a single atom. We're not really looking at molecules here. There's only the one element we're looking at. It's calcium. And we're just looking at really the single atom, but we're talking about molar mass. So we want to look at a mole of calcium, not a single atom like we normally would. We want to look at a whole mole. So we're looking at 6.02 times 10 to the 23rd atoms, or 1 mole of atoms. Now to find the molar mass, like I said, you just go to your periodic table and look up the atomic mass. That will tell you the mass of 1 mole of that atom. So the atomic mass is near 40, so we're going to say that the molar mass is 40 grams. It's always going to be measured in grams. Always remember to include your units. And then at the bottom, we're going to write our mole sentence, which basically describes everything that we have found out through this. We're going to say that 6.02 times 10 to the 23rd calcium atoms equals 1 mole, which equals 40 grams. This lets us know all the information that we really need to describe what's happening here. We're letting ourselves know that 1 mole is equal to 6.02 times 10 to the 23rd calcium atoms, and that the molar mass of that is 40 grams. Let's try another example, this time with molecule. We're looking at K2SO4. So, number of molecules that we're going to look at for the molar mass of that molecule, we want 1 mole of molecules, so 6.02 times 10 to the 23rd molecules. How many different elements do we have? We have 3 different elements we're looking at here. K, S, and O, potassium, sulfur, and oxygen. And number of atoms in each molecule, there's 2 potassiums, 1 sulfur, and 4 oxygens, so add those all up. We have 7 atoms in each of our molecules. So finding the molar mass for a whole molecule like this is a little more complicated than when you do it for just a single element. What you want to do is go to your periodic table and look up the molar mass for each of the elements that we're looking at. And you're going to multiply that by how many of that element there are. So for potassium, your periodic table tells you that the molar mass is 39. We're going to multiply that by 2 because there's 2 potassium atoms in this molecule. So that's going to equal 78. For sulfur, the periodic table tells us that the mass is 32. You only need to multiply that by 1 because there's just 1 atom. And then oxygen, the molar mass is 16. Multiply that times 4 because we have 4 oxygen atoms for a mass of 64. And then all you need to do is add all of those up to find your total molar mass, in this case being 174 grams. Remember, it's always going to be in grams. So that's what you need to do for solving for a molecule's molar mass. Find all the different molar masses on your periodic table for each element present, and then just add them all up at the end. And let's go ahead and write our mole sentence. 6.02 times 10 to the 23rd of our molecule K2SO4 equals 1 mole, and that mole equals 174 grams. All right, and here's just quickly at the end 5 helpful steps to find molar mass. First, list all the elements that are involved so you don't forget any of them. Second, write down the number of atoms for each element. Those are the subscripts after them. Take the number of that atom and multiply it by the element's atomic mass that you can find from the periodic table. Then add up all those atomic masses to find the total molar mass of the molecule, and then write your mole sentence. And always, again, remember to include your units in that mole sentence when you write it. If you follow these 5 steps, you won't forget anything required, and you'll be able to do it right every time. Right? Thank you for watching. If you have any questions, just ask me or your chemistry teacher for help.